One. Today we are going to see about some of the important chapters. In that, the third important one is about the moving charges and magnetism. See, in this case, the first two things about current, electricity, and semiconductor. Definitely, in case of NEET and EAMCET, you can have a 2 to 3 questions from that two chapter, and the third important chapter here is about moving charges and magnetism. And in this case, these are all some of the relevant things. This is moving charges is nothing but the moving of a flow of electron. Moving of charges, in this case, we just consider about the electron. Moving of electron, we call it as, that is about the current and magnetism, that is about electricity and magnetism. We are going to see about the moving charges and magnetism. Simple concept, all the names which are similar over here. See, for this one, next we'll see about the weightages. In this case, in case of NEET, what you are going to have here is 3 questions will be asked from this chapter, which is having a 6% of weightages. And in case of EAMCET, you may have a 2 questions from this chapter, which is very easy to solve, and direct questions will be there. No twisted oriented questions will be there in this one. Next one we'll see about next question here is. Okay, now the first one, magnetic field induction at the center of the circular coil. See, you just consider about the coil which is having a radius here is 5 centimeters. Always remember this one. In SI unit, we are going to use the radius or even a distance. Everything should be in meters. So we need to convert this one, right? And the current carrying here is zero point 0.9 ampere. See, even SI unit, that is the same here. So they have mentioned this one, and they have given the permittivity. They have given epsilon naught, that value we are going to find out this one, that is epsilon naught is the permittivity, and the permeability is about a mu naught, and your this one velocity of light here is 3 into 10 to the power 8 meter per second. Okay, now see velocity in this case, what they are asking in this one. See, in this case, what they are asking the questions, one thing you can understand from the options, you can find out what they are asking. And another one, see here, magnetic field induction at the center of the coil. So remaining the radius and all, you just forgot about this one. See, I will tell you here simply to understand this one. Simply I just mention here what I'm going to underline this one. You just avoid that one and you just read so that you can understand. I'm sorry, just a minute. Okay, now I will tell you here. See this one, you just avoid up to here. Now you read, you can understand what they are asking. See this one, magnetic field induction at the center of coil is. So magnetic induction they are asking here. Additional, they have given the information. That's all. Now you can understand here. So magnetic field induction here is, I just mentioned here, B is equal to mu naught. You just remember the formula, mu naught I divided by 2r. Okay, now see here, they haven't given about mu naught addition, but what they have given here is, see this one, they haven't given about mu naught value, but they have given about epsilon naught. We have to find out the relationship between epsilon naught and mu naught. See, r value given, I values has been given. I just substitute here in this case. See this one, mu naught, I just keep mu naught only, and the current they have given, this is 0.9 and divided by 2 into r values they have given. R value here is 5 into 10 power minus 2, right? Okay, now see, again I just simplify this one, mu naught into this one here is, I just mentioned as 0.9 divided by 5 into 2 here is 10, here is 10 power minus 2. Again, if you simplify here, 0.9 mu divided by this one will be cancelled here. So what you are going to have here is 10 power minus 1. Now, this is about the thing, but answer is not there. So what you are going to do here is, we are going to find out the relationship between mu naught and epsilon naught. See here, additionally they have given about velocity of light. See, from this one, c is equal to 1 divided by square root of mu naught epsilon naught. See, from this one, what I'm going to do here is, c square is equal to square on either side 1 divided by mu naught epsilon naught. That root will go here. See, again from this one, mu naught is equal to, from here what you are going to have here is 1 divided by epsilon naught c square. Now instead of this one, in this case In this formula, you just substitute the value of mu naught here. Now see this one here, mu naught I haven't mentioned here, I just mentioned this one mu naught. See, from this one, b is equal to, I just mentioned here, b is equal to mm, 0.9. Mu naught value here is 1 divided by epsilon naught into 3 into 10 to the power 8 meter square, 3 into 10 to the power 8 whole square, and additional what you are having here is zero point 0.9 I just mentioned here, that is 10 power minus 1. In numerator that will become 10 power plus 1, right? So what you are having here is 9 divided by epsilon naught into 9 into 10 power 16. So 9 and 9 will be cancelled here. So what you are going to have here is 1 divided by epsilon naught into 10 power 16. That is the answer. Next question. In an orbit of radius value they are given 0.5 angstrom. An electron revolves with the frequency they have given. Frequency here is 6.25 into 10 power 15 hertz. What they are asking in this question, so directly they have asked the questions. The magnetic induction field at the center of the coil. Now let me tell you here. For this one to understand better, let me tell you. See, you just consider a circular coil. Now see, in this way, whenever the electron is revolving in a circular orbit, now they are given the electron is revolving in this circular orbit with a frequency in this case, that means in per second how many times it will be revolving. Say for example, if the electrons are revolving one, see this one frequency f is equal to the electron revolving, say for example, electron revolving one full rotation per 1 second, so that is 1 hertz frequency. That means how many times it is revolving for 1 second here is, see this one, this is uh, 6.25 into 10 power 15 times it is rotating per second, that is about 1 hertz. Now this one I just tell you, in this case once the electron is revolving like this, what is the magnetic induction? This is the formula already, you know this one I just mentioned here. B is equal to mu naught I divided by 2R. Now see here, in this case I just mentioned here, mu naught value I just mentioned as, this is 4 pi into 10 power minus 7. Current value, they didn't give the current value, I just mentioned as I here, 2 into, and what they have given here is radius here is 0 0.5, 10 power angstrom. Angstrom means 10 power minus 10. Now you just multiply this one 0.5 into 2, or even you just mention as this is 1 by 2, 2 will be cancelled, so answer here is 1. Now this one I just mentioned here, for current I is equal to, what do you mean by current? Flow of charge. So that one I just mentioned here, q divided by t, charge by time, right? Now this one charge here is q is equal to, I just mentioned here, 1.6 into 10 power minus 19 coulomb, that is about the charge. And time here is, what they have given time here is frequency equal to inverse of time. So that's what they have given here. In this case I just mentioned here, instead of t, see I just mentioned in this case I equal to q into f, right? Now in this case I just mentioned here again, this one here is 4 pi into 10 power minus 7 into I, instead of I just mentioned as q into f, divided by here is 10 power minus 10. Now this one I just mentioned here, 4 pi into 10 power minus 7. Charge here is 1.6 into 10 power minus 19, and the frequency what they have given, the frequency value here is 6.25 into 10 power 15 plus 15, and here this one denominator 10 power minus 10, in numerator this will become 10 power 10. Now this one you just add these two together, that one what you are going to have here is 4 pi into 10 power minus 26 here, and into 1.6 into 6.25 into this one here is 10 power plus 25. So these two will be cancelled here. What you are having here is 10 power minus 1. If you multiply these two together, what you are going to have here is 10. Now this one here is 4 pi into 10 power minus 1 into 10. So final answer here is 4 pi Tesla. The next problem here is the electric current in a circular coil of two turns. There are two turn of a circular coil of a magnetic induction here is 0.2 Tesla. See here, you just highlight these 2 turns, that is produce a magnetic induction here is 0.2 Tesla. The, the coil is unwound and rewound into 4 turns. See here, second time here is 4 turns. What is the magnetic induction? For 2 turns, this is 0.2 Tesla. For 4 turns, what is the magnetic field induction? That one only we are going to find out. That's all. Simple thing. See here, I just mentioned in this case the first one, the formula here is B is equal to, I just mentioned here, B is equal to mu naught I divided by 2R. This is coil number of this one here is coil which is having a radius, and here is this is about the current flow. See here, what they have mentioned here is the current flow is the same current, so I will be the same, but here the turns will play a major role. So this one number of turns, see in this one here is only, see here, this one what I have mentioned here is only one coil. If you are having number of turns, in this case I just mentioned here n into mu naught I divided by this one I just mentioned here 2 into R. See for this one, see here in this case, suppose which is having two number of turns, that is 2 here, radius they have given here. See in this case, two coils with the two radius, the same one if the coil is wound into four number of turns of the same radius. See for this one, let me tell you in this case, the first one here is, see this one I will tell you what it means that length here is. Say for example, if you consider about coil, see if it is like this is about the circular coil. If it is having two number of turns, I just mentioned here two turns which will be there, what is the total length here is L is equal to, for single coil length here is will be equal to circumference of the circle, but here you are having two turns which is having the same radius, that means 4 pi r. That's what they are mentioned in this case. You can observe here, length here is 2 into 2 pi r1, first one radius, so from here r1 equal to 1 by 4 pi here. Now this is unwound and which has been rewound for 4 turns. So this one in this case, now you just substitute the value b1 equal to mu naught, number of turns here is 2 turn, I divided by 2 pi r1. So substitute all the values. So from here what you are going to have here is, so instead of r, you are going to substitute this value. Now find out, this is b1. This value will be equal to 0.2 Tesla. Now next one, see here, this one will become 4 number of turns. From here r2 is equal to, now substitute the value here. This is b1 and this is b2. Find out the ratio of b1 and b2, and already you know this one, b1 value here is 0.2 Tesla. Now b1 by b2 here is what you are going to have here is 4 by 16. See here, mu naught I L1 everything will be cancelled here. From this one what you are going to have here is 4 by 16. From here b2 equal to 4 into b1 value already know, substitute the value, and what you are going to have here is 0.8 Tesla. This is the answer. The next problem here is a wire carrying 100 ampere. So current, a wire of carrying current 100 ampere. Now it's bent into a circular loop which is having a radius of 5 centimeter. Now what they are asking here is the flux density at its center. Flux density or even magnetic inductions, both in this case are similar over here. See for this one, let me tell you in this case. See for as we know this one, magnetic induction formula here is B is equal to this one here, mu naught I divided by 2R, and even if you are having n number of turns means, so you can mention here as n. So only thing here is mu naught value here is 4 pi into 10 power minus 7, and the current value what they have given here is 100 ampere of current, and divided by 2 into radius, how much what they have given, that value here is 5 centimeter, that is 5 into 10 power minus 2. Now this one 5 into 10, see here, this is a 5 into 10 here is 5 into 2 here is 10, 110 will go, and even only thing is, see I just mentioned here 5 into 2 is 10, so here 1 will go, so what you are having here is minus 1. This one will go here, that is an from a numerator, so I just mentioned here 4 pi into 10 power minus 7, and this one 100 I just mentioned as 10 square, and this one 10 power minus 1 will come as 10 power 1. So what you are going to have here is 4 into pi value I just mentioned here 3.14 into 10 power minus 7, and this one here is 10 power 3. So what you are having here is, you just multiply this one Once you are going to multiply with this, the value here is 12.56 into 10 power minus 4 Tesla. So answer here is this one. The next problem here is a circular arc. See here, a circular arc of a wire subtended an angle of pi by 2 at the center. It, if it carries a current I and its radius of curvature is r, then magnetic field at the center of the arc. See this one, let me tell you what I mean that here. I just draw and I'll show you over here. See this one, you just consider arc. This is like a circular arc which subtended an angle. What they have given here is pi by 2. Pi by 2 in this case you just mentioned here. This one here is pi by 2, that is 90 degree. So arc here is this will come, that is about one quarter of the circle. This one, this is angle here is 90 degree, and the radius of curvature here is capital R, and even the current flow in this coil or even a wire here is they are mentioned as I. In this case what they are asking in this one, magnetic field. See here, whenever the current carrying towards the coil at the center, if it is in a circular arc, if it is maintained as a circular arc at the center, what is the magnetic field? That's what they are asking here. See, let me show you that a theoretical part of this one. So, similar like this. See here, if the wire is made into a form of an arc, it make an angle theta, but here is they have already mentioned this one 90 degree. Here if it is in a theta, so the magnetic induction at the center here is mu naught I by 4 pi r. Remember here, 4 pi r into theta. Theta is the angle between the arc, between the either side of the arc. This one, according to this I just mentioned here. For this one you just mention the formula here. B is equal to mu naught, I just mentioned as mu naught I divided by 2 pi, and even r here is capital R, and angle here is pi by 2. Now this one, this is 4 pi r, I'm sorry, this is 4 pi r here. So you just multiply this one. So answer here is mu naught I pi divided by uh, 8 pi r. Here pi will be cancelled here. So what you are going to have here is answer is mu naught I divided by 8 r. So this is the answer here. Okay, next problem here is a circular coil. Now you just consider a coil which is in a circular shape of radius r and has n turns, n number of turns, and carries a current is I. Now what they are asking, the magnetic induction at a point on the axis. See, now you just consider about the coil along the axis of the coil at a distance here is, they have given the distance here is root 3 into r from its center. See this one, this is not root 3 r, this is root 3, only numerics only having root 3 into r from its radius. Now this one, for this let me show you some theoretical part of it. See here, a magnetic field at a point along the axis. This is about along the axis, which is at the distance here is x, r is about a radius, and I is about the current passing through the coil. For this one, the magnetic induction at the center here is mu naught Ni r square divided by 2 into r square plus x square whole power 3 by 2. Now for this one, I just going to substitute the values in this equation. See here, for this B is equal to, see I just mentioned here, mu naught N I r square divided by, now this one I just mentioned here, 2 into r square, and already they have given x value here is root 3 into r whole square, and whole power, this whole power 3 by 2. Now I just mention again the same. See in this case, mu naught N I r square divided by 2 into, so this one here is r square, and the this one you are going to take a square of this one, root 3 here is 3 into r square and whole power 3 by 2. Now r square plus 3r square here is 4r square. So this one remaining thing I just write on here, mu naught N I r square divided by 2 into, here is 4r square, 4r square whole cube. Now this one, how you are going to whole power 3 by 2. Now this one here is, first you just take a root and make a cube. See for this one I just mentioned here, mu naught, again I just mentioned mu naught Ni r square divided by 2 into, take a root of this one here is 2r whole cube. So from here what you are having here is mu naught Ni r square divided by, so this one cube here is 3, 2 cube here is 8, 8 r cube, 8 r cube into 2. So what you are going to have here is this 8 into 2, 16 you are going to have, and r cube here is, this one will be cancelled here, only 16r. So denominator here is only 16r. So answer in this case, that's all. The next problem here is, if B is the magnetic induction at the center of the coil of radius R and carrying a current I, and its magnetic induction what they have given here is 1 Tesla. Now listen here, similar here, it makes little confused, you just concentrate here. B is the magnetic induction, and at the center of the coil or carrying a current is, that is 1 Tesla. From here, see, from this one at the center to the current, that is about the connecting board. If you forget about this one, the magnetic induction is 1 Tesla. That's all. It then its value at a distance of root 3 into r, similar like a previous problem we have seen along the axis. Previous one we have seen that value here is 1 by 16 in mu naught. That's what the same value here, but one. Now see here, from the center, what they are asking this value from the center with the distance here is how much their value if b value here is 1 Tesla. See this one, I just show you the similar one. See, this is about, in this first case, x equal to 0, there you are having a magnetic induction is 1 Tesla. For then this case already we found the value, that is 1 by 16 of this value. Now let me show you in this case. For this, let me tell you here, say this one, b is equal to, at x is equal to 0, so here is b is equal to, that one I just mentioned here, b is equal to, I just mentioned as b1. For example, in the first case, mu naught, see here, mu naught Ni r square divided by 2 into r square plus 0 whole power 3 by 2. Now this one r square plus 0 here is r square, and if you take root, what you are going to have here is, I just mentioned here, mu naught Ni r square divided by 2 into r cube. Again you just cancel this one, so what you are going to have here is mu naught Ni divided by 2r. That's all. So this value what they have given here is, this value will be equal to 1 Tesla. Now the similar concept I just mentioned here, if x is equal to square root of 3 into r, that's one we have already found out the previous answer. You just go through on this one, that value here is, see here, in this case b2 I just mentioned here, in this one the value here is mu naught, see here, mu naught Ni divided by, so previous one if you see this one, that value here is 16 r, right? This one I just mentioned here. In this case, similar one, mu naught Ni divided by 8 into 2r, right? If you mention this one, see here, 8 into 2r, if you mention this one, that value already we know, that one, that value here is 1 Tesla, right? And this one, that is b1. So 1 divided by 8 into b1, that is the value already they have given. You just see here, you can understand this one. So from this, b2 is equal to, so b1 by 8 or even 1 by 8 Tesla. b1 value already they have given 1 Tesla, so answer here is 1 by 8 Tesla. The next question here is, a circular coil name is A has a radius R and a current flowing through the coil is I. Another circular coil name is B and radius here is 2R and current flow here is 2I. And then what they are asking, then the magnetic field at the center of the circular coil are in the ratio. So that's what they are asking here. First one I just mentioned in this case, first circular coil, see I just mentioned here, this is about the first circular coil which is having radius here is R and the current flow here is I. Okay, now this is circular coil A, and another one, another circular coil I just mentioned here, that is about circular coil here is B, which is radius here is, I just mentioned here, consider this one, this radius here is 2R and the current flow in this case here is, that is 2I. So this one here is B, right? Okay, now what they are asking in this case here is, so they are asking about the magnetic induction for the first one I just mentioned here. B1 is equal to mu naught I divided by 2 into R. For the second case, similarly, here B2 I just mentioned here, B2 is equal to mu naught, and here current here is, for this one I just mentioned as I, here current here is, this is 2I, and 2 into radius here is 2r. See, for this one I just mentioned here, 2 will be cancelled here, so that what you are going to have here is mu naught I divided by 2r. That one will be equal to B1. Already that will be equal to B1. So B2 divided by B1, or even B1, you just take this side, B1 divided by B2 will be equal to 1 is to 1, or even 1 by 1. So answer in this case here is 1 by 1. Next problem here is two circular coil of radius 20 centimeter and 30 centimeter, having a number of turns here is 50 and 100, made up of material, same material. See this one, they are having same material, are connected in series. See, 2 points you need to highlight over here. One is about the same material and which are connected in series. Now what they are asking here is the ratio of magnetic field induction at their center. So this one from the center in this case, hope you remember this one, for the magnetic field induction at the center I just mentioned here. So B is equal to mu naught I divided by 2R. This is the formula. And two highlight points, one is about the same material and another one, both are connected in series. See, in series connection already we have seen about this one. In case of current electricity, in series connection, current will be the same and the potential difference V will be differ, right? Similarly, in case of a parallel connection, hope you remember this one, parallel connection here, I will be differ, and in case of potential will be the same. Hope you remember this one. For example, I just show you with the help of this example. See here, both the resistors are connected in parallel in this case. See here, this one in this case, see here, you can understand here, potential will be the same, but current here is, this one is I1 and this one is I2. Similar like this, suppose if you consider over here, see in this case, see this one, this is V1 here, and here we can mention here this is V2 in this case, but current here is, even in this case this is I, here also I. So current will be the same, potential difference will be differ in case of series connection. So here for this one I just mentioned here, mu naught is equal to, see what they have mentioned here is two circular coil of radius they have given, and additional what they have given here is number of turns. So here is number of turns, in this case you have to mention this one n. V1 here is n1 and radius is going to change r1. Next one here is B2 is equal to mu naught I and n2 divided by 2 into r2. Now what they are asking in this case, B1 divided by B2. Now I just mentioned here, B1 is equal to mu naught I n1 divided by 2R1. Similarly, divided by B2 here is 2R2 divided by mu naught I N2. See, the what are the common terms? We just cancel over here. So 2 and 2 will be cancelled here. Mu naught I will be cancelled over here. Mu naught into I will be cancelled here. So what you are going to have here is N1 divided by N2 into R2 divided by R1. Now substitute the value N1 and N2, what they have given here is, see, you can see here, this is about N1 and this is about N2. N1 and N2 here is 50 divided by 100 into R2 here is what they have given, 30. 30 divided by 20 centimeter. Even you just convert this one 10 power minus 2 into 10 power minus 2 meter. This one 10 power minus 2, 10 power minus 2 will be cancelled. In case of ratio, no need to convert this one. And here is, this is 1 by 2. So what you are going to have, this 0 and 0 will be cancelled here. That is 30 divided by 40, and this one will be cancelled here. So what you are going to have here is 3 divided by 4. That is B1 by B2. Answer here is 3 divided by 4. Okay, now the next problem here is 2 ampere current is flowing in a circular coil of n turns, n number of turns of coil having 10 centimeter radius. The flux density, that is B value they have given, 0.126 into 10 power minus 2 Weber per meter square. The value of n. So what they are asking here is they are asking us to find out the value of n. See, before going to that, what is the formula? Magnetic induction and even a flux density, both are similar over here. B is equal to mu naught. See here, mu naught Ni divided by 2R. So this one, B value they have given, mu naught value given, I value given, and R value given. They are asking us to find out what is N value. N is equal to 2R into B value what they have given, that is 0.126. B divided by mu naught into I. Now you just substitute all the values over here. 2 into R value here is 10 centimeter, that is 10 into 10 power minus 2 meter here, into, and this one I value, see from this one 2R into B value they have given here is 0.126 into 10 power minus 2. Now whole divided by, this one I just mentioned here, whole divided by mu naught here is 4 pi into current value into 10 power minus mu naught here is 4 pi into 10 power minus 7 into current value, how much they have given here is 2 ampere current. Now this one you just cancel the common terms over here. See, 2 and 2 will be cancelled here, this 2 and this 2 will be cancelled here, and see here this is 10 power minus 2 and this is 10 power minus 2, and here 10 power minus 7 will be cancelled, and what you're going to have here is 10 power minus 3. I just mentioned here 10 power minus 3. And now this one, what are the terms are there? This one 10 is there and 0.126 is there. 0.126 into 10 is there, 10 plus this one 10 power minus 3, it will come to the numerators, that one is 10 power plus 3, and the whole 10 all add together, that is 10 power 4 divided by this one here is 4 pi. Now this one, from this one I just mentioned here, this one here is 126 into this one 10, that is 10 into 10, this one divided by 4 into 3.14. Now you just multiply over here, this is 1260, this one uh, yeah, this is 1260, and divided by, you just multiply over here, this one what you are going to have here is 4 into 4 16, 4 5 over here, and this one here is 12 now. So what you are going to have here is 12 about this one, so you just cancel here, what you are going to have here is 100. So 100 number of terms, so answer here is 100. Okay, now next question here is two circular coil. There are two coils are made up of identical similar wire. Length of the wire is constant, that is 20 centimeter. One coil which is made into 9 turns, another coil which is made into 3 turns. 9 turn means radius will be less. 3 turn means radius will be little more. For the second one radius is more, first one is radius is less, but number of turns here is 9, here is 3. Now, if the same current flowing through the coil, current will be the same, then what they are asking, the magnetic field induction B value at the center ratio. They are asking about the ratio of B1 to B2. Now, let me tell you here, the first case I just mentioned here. See, one important concept here is length will be 20 centimeter and one turn, that is 9, and the second one is 3 number of turns. For example, I just mentioned here, for L is equal to, L here is, already we know this one. See, this is about a circular coil. See, this is what they have made here is, this is a 9 number of turns, N is equal to 9. So L here is, what I have mentioned here is, L is equal to 2 pi, this one I just mentioned here, R1, 2 pi r1 into n number of turns. So I just mentioned here n1 or even n number of turns, and radius here is r, so that you can mention over here. See, this one 2 pi r and here is n1 only. I just mentioned this one as 2 pi r and n1. See, from this one L is about constant here. See, from this one, what I'm going to mention here is R is equal to L divided by 2 pi into N. See, L constant, 2 pi also constant, so R is proportional to 1 by N. Okay, now next one, magnetic field induction at the center B is equal to, what you are going to have here is mu naught N I divided by 2 into R. For the first case, what I'm going to mention here is, for even in this case, see, for the first one I just mentioned here, B is proportional to what you are going to have. See, only thing is mu naught is a constant, I also constant, same current, 2 also constant. From this one, B is proportional to N divided by R. Already we know this value. So N divided by R value here is again 1 by N. So B is proportional to N square. That's all. For the first case, for magnetic induction for 9 number of turns here is, I just mentioned here, N1 square, that is about 9 square, and B2 here is, that is about 3 square. Now what they are asking here is B1 divided by B2. That one will be equal to 9 square divided by 3 square. So what you are going to have, 3 square, 1 9 will be cancelled here. So 9 divided by 1. So answer in this case here is B1 by B2 equal to 9 is to 1. Okay, the next question here is, a electron revolve in a circle of radius. Now, the electron is revolving in a circular orbit of radius they have given with the velocity speed they have given, that is 10 power 6 meter per second, in a hydrogen atom. Now, you just consider a hydrogen atom in the first orbital. The electron is revolving with a radius of 0.4 angstrom and the speed they have given. The magnetic field, listen here, the magnetic field produced at the center of the orbit due to the motion of the electron. See, electron is moving in a circular orbit. That means whenever the electron, see here, I just show you the circle over here. Whenever an electron moving in a circular orbit, a movement of the electron, that is about the charge of the electron, it produces the current. Around the current, it produces the magnetic field. Whenever there is a charge is moving over here, so the magnetic field will be produced at the center. Now, the electron moving with velocity they have given. From this one we are going to find out what is B value here. See, first I just mentioned here. See, in this case, what are the things they have given here is, so this is about the electron, see, which is moving with velocity they have given, V value they have given, that is 10 power 6, and from here radius they have given, the radius value here is 0.4 angstrom, that is 0.4 into 10 power minus 10. Now what they are asking here is magnetic field produced at the center, or even magnetic induction. I just mentioned here B is equal to mu naught, see here, mu naught I divided by 2R. See, this is about a number of coil. In this case you can mention as N, but here is only R bit they have mentioned this one. Next one here is, they haven't given about the current, so that I just mentioned here, current here is, I just mentioned this one, current I is equal to charge over a time. So this one Q divided by T here is current, I just mentioned here, this is Q divided by T, I just mentioned as T into 2R. Now T is about the time period. Now hope you remember how you can get time here is, so related to the velocity. Velocity will be equal to distance by time. Distance is nothing but the electron which is revolving in the circular orbit. That one here is circumference of the circle, I just mentioned here, 2 pi r divided by T. That one will be equal to velocity. From this one T is equal to 2, I just mentioned here, 2 pi r divided by V. Now you just substitute over here. This one, see here, mu naught into Q divided by T value here is, I just mentioned as 2 pi r into 2r, and denominator V will come over here. See, from this one again I just mentioned here, mu naught Q into, here is R is V, I just mentioned as velocity V divided by 4 pi r square. Now substitute all the value. Mu naught value here is 4 pi into 10 power minus 7 into charge of the electron. Charge of the electron here is 1.6 into 10 power minus 19 coulomb. Next one, into velocity, already they have mentioned, that is about 10 power 6 meter per second divided by, again here, that is about 4 pi into radius, already they have given 4 pi r square. Radius here is, I just mentioned as 0.4 into 10 power minus 10 angstrom, in this case 10 power minus 10. We just multiply again here, r square, this one 0.4 again into 10 power minus 10. See, from this one you just cancel here, this is 19, and from this one this is about 20 here. Now from this one what you are going to have here is 10 power minus 1 pending is there, and even 4 pi will be cancelled over here. Now See what are the things over here. Say remaining thing I just write down here, 10 power minus 7 into this one here is 1.6 into 10 power 6. You just cancel here. So what you are having here is 10 power minus 1 and divided by zero point 0.4. I just mentioned here 0.4 into 0.4, and here again you are having 10 power minus 1 additional is this one is there. No, this one will be cancelled. Now zero point 0.4 into zero point 0.4 you just cancel here. So what you are going to have here is this one I just mentioned here. For example, this one here is 16 into, for example I just mentioned here 1.6. I just mentioned multiply and divided by 10 over here. See this one I just mentioned like this, whole divided by this one will become 16 divided by 10, and the denominator what you are going to have here is 0.4. zero point 0.4 into zero point 0.4 into 100 divided by 100. I just mentioned like this. So what you are going to have, you can easily cancel with this one. So from this one you can have 4 into 4, 4 into 4 divided by 100 is there. So 16 will be cancelled here, 110 and one cipher will be cancelled here. This one numerator will come in, denominator will come in numerator. So what you are going to have here is B is equal to 10 Tesla. Continuation of this presentation, still more important problems and old question paper discussions will be done on in the next session. It will be given in this link. You just go through on this.